Hello, I want to share some comments about assignment 7 with you. It's not about one particular problem, but it's more about how to write what you do and how to decide which trigonometric ratio you use to solve a problem. So the first example I want to begin with, it's going to be just a right angle triangle. Doesn't have to look pretty, I just need to okay. Well, if it looks pretty, doesn't matter. I just need to add the information. So let's say that in this case, we know that this angle over here is 56 degrees. And, well, that angle is a right angle. And we also know that this side is 8 meters. And this is example 1. We want to solve this triangle. So that means we want to find the angle we are missing over here. Say alpha. We want to find the side we are missing here, x, and the other side, the hypotenuse, y. Let's begin by finding the side, the angle alpha, because that's the easiest. We know that to find alpha, we need to do 90 degrees minus 56 degrees, because we know that the sum of the angles, the three angles have to sum to 180, so if we have one that is already 90, the other two have to sum to 90 as well. So we know that this angle is 34 degrees. And we are done with finding the angles. Now we would like to find the side x. The side x here is next to our angle 56 degrees. By the way, we are only going to use the information in blue to find the new sides and that we are missing, because even if it was easy to find the angle over here, we could have made a mistake anyways. So it's always safer to only use the information that was given to find new information. So this angle 56 degrees is next to the side x. So we may be tempted to say that when we are finding x, we can use the cosine of 56 degrees, because then we will use the side who is adjacent to that, so x divided by the hypotenuse, which in this case is y. And here we see that this is not going to work. I mean, it's perfectly true that cosine of 56 degrees is x divided by y, but we don't know neither x nor y, so this is not going to work. So we try something that doesn't work. So let me just erase, and we need to try something else. So going back to what we know the side that is next to it. We want to find the side that is next to it, and we know the side that is opposite. So we need to use a trigonometric ratio that involves the side that is opposite. So we're going to use the tangent. Why? I made it. Let me erase that and look nice. Again, we want to use the tangent of 56 degrees. So tangent of 56 degrees is the same as tangent is opposite to the angle divided by adjacent. So opposite to 56, we have 8 divided by adjacent to 56, we have x. So we just need to do algebra to find what is x. You may think, do you like x dividing over there? No, we don't, because we want to find the value of x. So we want this x to cancel, so we multiply by x on both sides. So on this side it cancels, and then we will be saying that x times tangent of 56 is equal to 8. but we want x alone, so we divide both sides by tangent of 56. So they cancel on the left-hand side, and we can finally say, what is x? X is 8 divided by tangent of 56 degrees. What is that? Let's check in the calculator. I have it over here. So I say 8 divided by tangent of 56 degrees. Doesn't matter, your calculator doesn't have to look this fancy, but you should get that result. So this is saying 5.39607. We want 3 significant figures, always, unless the problem sign is something else. So we count 4. 1, 2, 3, 4. Number 4 is the number 6. So we need to ask ourselves, is the number 6 going to change the 9 or not? Yes, it's going to make it round up. So let me write it over here. We are here, so obviously we say this was 5.396, and we don't care about what comes after. The 6 is going to round the 9 up. So this is going to be 5.40 meters, rounded to 3 significant figures, as we usually do. We would like to find y now. And we again want to use only the information that was given at the beginning, so the angle 56 degrees and the side 8. So let me write here, finding y. If I know the side opposite to 56 and I want to find the hypotenuse, we will use the sine. Yes, that's right. Sine of 56 degrees is going to be the same as 8 divided by y, and we are trying to find y. So this is going to be the same simplification we did over here. You can pause the video now and try to do it yourself, and you should get that y is the same as 8 divided by sine of 56. So let's check in the calculator what this is. 8 divided by sine of 56. Okay, let's look at the rounding. 9.649, and I don't care what comes after that. I only care up to the fourth significant figure. So let me write it over here. 9.649, blah blah. And if we round this to 3 significant figures, we have to decide whether the 9 is going to change the 4 or not. And yes, it's going to change it. So it's going to be 9.65 meters. So now let's check if these results make sense and if we can check whether our work is correct or not. First of all, if we compare the two legs of the right angle triangle, the smaller one should be the one in front of the smaller angle, so in front of alpha. So we know that x has to be less than 8, and we got 5.0, so that makes sense. Then we know that the hypotenuse has to be more than 8, and we got 9.65, so that makes sense. We can use Pythagoras to check whether the sides are correct or not. We are just going to check with the approximations. So we could be off a little bit, but that's okay. We're just checking in general. So we like to see if it's true that 8 squared plus x squared is the same as y squared, because y is the hypotenuse here. So we are trying to see if it's true that 8 squared plus 5.40 squared is approximately the same as 9.65. The approximately is because, as I said, we are using approximations. So we may be off by a little bit. So let's check in the calculator. 8 squared plus 5.40 squared. Okay, we got 93.16. And now let's check how much is 9.65 squared. And we see that we are off by a few decimals, but that's enough just for checking that the result makes sense. So I'll just write here is calculator. And this was the first example I wanted to show you. Before I stop this video, imagine that you were doing this very fast and then you didn't draw the triangle over here. Let me see here. I'm going to remove the triangle. Yeah. So now imagine it's June and you are checking your assignments because you are reviewing for the test. What will you prefer to see? This problem solved in your assignment, where it's correct or not, or this one, where you actually have the triangle and you know what you're talking about. I think I would rather have the triangle over there. So even if the triangle is on the assignment sketch, I'll say sketch it on your work as well. So later on, when you have to review your work, you know what you're talking about.